In the heart of South America lies a world so vast, so ancient, and so mysterious that even today it remains only partially understood. A living giant of clouds, rivers, and endless green. A place where evolution has been allowed to run wild for millions of years, shaping creatures, cultures, and landscapes unlike anywhere else on Earth. This is the Amazon rainforest, one of the last true frontiers of our planet. For centuries, explorers, scientists, and storytellers have tried to capture its essence. Yet, the Amazon refuses to be fully known. Beneath its canopy hide civilizations lost to time, animals found nowhere else, and natural wonders that operate on a scale almost too great for the human mind to grasp. Its rivers carry more water than any other river system on Earth. Its trees breathe out moisture that becomes rain for entire continents. And its soil, dark, ancient, full of secrets, remembers histories far older than humanity itself. This documentary takes you deep into that world. A calm journey through the science, the legends, the discoveries, and the untold stories that make the Amazon one of the most extraordinary places on Earth. Each chapter explores a different part of its identity, from its geological birth and unmatched biodiversity to its hidden tribes, forgotten civilizations, and the modern technologies now revealing what the forest has kept hidden for thousands of years. As you listen, allow yourself to drift into the slow rhythm of the rainforest, the steady breath of its rivers, the pulse of its storms, the quiet intelligence of the life it shelters. If you enjoy these deep dive explorations into the mysteries of our planet, feel free to stay connected to this journey. Many viewers choose to subscribe or leave a small sign of support, not out of obligation, but simply to keep these stories alive and to help this channel continue exploring the wonders of our world. Now, let us begin our descent into the greatest rainforest on Earth. A place where past and present meet, where science and myth intertwine, and where the future of the planet may ultimately be decided. The story of the Amazon River begins long before the first humans walked the Earth. It reaches back tens of millions of years into a world where the landscape of South America looked nothing like it does today. The Amazon, we now know as the largest river system on the planet, is the result of powerful geological transformations, ancient inland seas, and dramatic shifts in the Earth's crust. Understanding the origin of the Amazon is like reading a history carved into stone, water, and time itself. To imagine the early Amazon, we must travel back roughly 100 million years, during the late Cretaceous period. At that time, South America was still connected to Africa as part of the supercontinent Gondwana. Dense forests covered much of the land, but the river systems were entirely different. When South America and Africa finally began separating, the landmass started drifting westward, forming the Atlantic Ocean. This continental drift, driven by plate tectonics, set the foundation for the Amazon basin as we recognize it today. Around 65 million years ago, when dinosaurs went extinct, South America had already become a floating continent. Cut off from the rest of the world, its ecosystems evolved in isolation. What is now the Amazon basin remained mostly a series of wetlands, lakes, and slow-moving rivers that drained westward into the Pacific Ocean. This is one of the most surprising facts about the Amazon's early history. The river originally flowed in the opposite direction. Everything changed when the Andes Mountains began to rise. This mountain-building process, called the Andean orogeny, was triggered by the Nazca tectonic plate subducting beneath the South American plate. The uplift was slow but relentless. Over millions of years, the western part of the continent rose higher and higher, blocking the ancient rivers that once drained toward the Pacific. The Andes acted like a massive wall, forcing the continent's drainage patterns to shift. This geological revolution marks the true beginning of the Amazon River. By around 23 million years ago, during the Miocene epoch, the formation of the Andes had created an enormous depression in the center of the continent. This basin filled with water, forming what scientists call the P-Bar system, a giant swamp-like inland sea stretching thousands of kilometers. It was a world of crocodile-sized reptiles, massive fish, and early mammals. Fossils discovered in Peru and Brazil reveal that the region hosted a unique ecosystem where freshwater and marine species lived side by side. The P-Bar system existed for millions of years. Slowly, sediments carried from the rising Andes began to fill the basin. Rainfall increased as the mountains grew, and the water flow intensified. More sediment accumulated, creating vast floodplains and reshaping the region's geography. Eventually, the inland sea began to drain eastward. This gradual redirection of water flow marked the birth of the Amazon River's modern course. By approximately 10 to 11 million years ago, geological evidence shows that the Amazon had begun flowing from west to east toward the Atlantic Ocean. This reversal in direction was one of the most dramatic hydrological shifts in Earth's history. As the river carved its path across the continent, it created a network of tributaries that now form the world's most extensive drainage system. Today, the Amazon drains an area of over 7 million square kilometers, roughly the size of the entire United States. Around 2.5 million years ago, during the Pleistocene, the Amazon River we recognize today fully emerged, with powerful rainfall cycles and climatic fluctuations shaping its floodplains. The river deepened its channel and expanded its basin. The rainforest also began to develop in its modern form. Scientists believe that the Amazon rainforest is at least 55 million years old, but its current structure, with its astonishing biodiversity, is largely the result of the stable, humid climate that developed during this time. One of the most extraordinary facts about the Amazon River is the sheer amount of water it carries. Today, the Amazon releases approximately 209,000 cubic meters of water per second into the Atlantic Ocean, more than the next 7 largest rivers combined. This immense flow has shaped not only the continent, but also the ocean itself. The plume of fresh water extending from the Amazon's mouth can spread more than 300 kilometers out to sea, influencing marine life and even weather patterns. The river's sediments tell another part of its story. Tiny grains of rock, carried from the Andes over millions of years, have created the fertile soils and rich floodplains that sustain the rainforest. These sediments also preserve fossils that help scientists reconstruct the region's ancient ecosystems. Discoveries of giant caimans, prehistoric dolphins, and extinct species of turtles offer a glimpse into a lost world shaped by geological change. The birth of the Amazon is not just a story of geology. It is also a story of life adapting to dramatic transformations. As the river reversed direction and the P-Bar system disappeared, species were forced to evolve or vanish. Fish diversified into thousands of species, each adapted to specific conditions, from murky floodwaters to fast-flowing tributaries. Plants evolved strategies to survive seasonal flooding, including the remarkable ability of some trees to grow underwater for months at a time. Even today, the Amazon basin continues to change. The Andes are still rising, the river is still carving new channels, and the rainforest is constantly shifting. In many ways, the Amazon is a living geological experiment, one that reminds us how long and complex Earth's history truly is. Understanding the river's origin also highlights how delicate the system is. The Amazon's formation depended on a balance of tectonic forces, climate stability, and ecological evolution. Modern threats such as deforestation and climate change risk disrupting processes that took millions of years to develop. Knowing how the Amazon was born helps us appreciate what is at stake. In the end, the Amazon River is more than a body of water. It is the result of ancient mountains rising, continents drifting apart, seas forming and disappearing, and ecosystems evolving through deep time. Every drop of water flowing through it carries a fragment of that history. To explore the Amazon is to witness the memory of the Earth itself. The Amazon rainforest is often described as the most biodiverse place on Earth, and this is no exaggeration. Scientists estimate that the region is home to 10% of all known species living today, and possibly millions more that remain undiscovered. It is a biological treasure chest overflowing with life, from the smallest bacteria to the most elusive mammals. Exploring the Amazon is like entering a living library of evolution, where every plant, insect, and animal tells a story millions of years in the making. When we look at the rainforest from above, it appears as a vast carpet of green, stretching across 9 countries and covering more than 5.5 million square kilometers. But beneath this green canopy lies an astonishing complexity. A single square kilometer of Amazon rainforest may contain over 1,000 tree species, more than most countries on Earth. Some trees rise over 60 meters high, forming the canopy layer, while countless others thrive in the understory and forest floor, each adapted to specific conditions of light, humidity, and soil. One of the most intriguing aspects of Amazonian biodiversity is how unevenly distributed it is. Certain pockets, known as hotspots, contain unusually high concentrations of species found nowhere else. These hotspots are shaped by the region's ancient geological history, rainfall patterns, soil chemistry, and even the shifting paths of rivers over time. In these areas, evolution acts like a sculptor, refining life into unique forms that can exist only in that specific corner of the world. The sheer variety of plant life is staggering. Scientists estimate that the Amazon contains over 40,000 plant species, many of which play vital ecological roles. Some trees provide food for thousands of animals, while others produce chemical compounds that protect them from insects or fungi. These chemicals are so diverse that pharmaceutical researchers consider the rainforest one of the most promising places on the planet for new medicines. In fact, around 25% of modern drugs originate from rainforest plants, even though less than 1% of Amazonian species have been studied for medical use. The Amazon is also home to some of the most fascinating and unusual plants found anywhere. Carnivorous species such as bladderworts capture tiny aquatic organisms using vacuum-like traps. Giant water lilies grow leaves over 2 meters across, strong enough to support the weight of a child. And certain trees, like the walking palm, may literally move over time by growing new roots in the direction of better sunlight. These botanical marvels show how inventive evolution can be when given millions of years and an environment full of competition and opportunity. Animal life in the Amazon is equally extraordinary. The region supports more than 400 species of mammals, including jaguars, giant anteaters, pink river dolphins, and woolly monkeys. Some species, like the jaguar, are apex predators that rely on the forest's complexity to hunt and survive. Others, such as sloths, move slowly through the treetops, using camouflage and a symbiotic relationship with algae to avoid predators. Pink river dolphins, known as botos, navigate murky waters with highly developed echolocation, adapting perfectly to their flooded forest environment. Bird diversity is even more impressive. The Amazon hosts over 1,300 species of birds, about 1/3 of all bird species in South America. Among them are vibrant macaws, tiny hummingbirds, and secretive forest eagles. Some birds migrate thousands of kilometers each year, relying on the rainforest as a vital stopover, while others never leave the territory in which they were born. The harpy eagle, one of the most powerful birds of prey in the world, depends on tall, old-growth trees for nesting, making it especially vulnerable to deforestation. Yet, it is the insects that truly define the Amazon's biodiversity. Entomologists believe there may be up to 30 million insect species in the region, though only a fraction have been catalogued. Ants alone exhibit extraordinary variety. The leafcutter ants, for example, form colonies of millions and maintain underground fungal gardens that function like highly organized agricultural systems. Bullet ants deliver one of the most painful stings known to humans, while army ants move in massive swarms, reshaping the forest ecosystem as they travel. Butterflies in the Amazon are equally remarkable. The region's iconic blue morpho butterfly, with its iridescent wings, reflects light in a way that creates a metallic blue shimmer, an effect produced not by pigment, but by microscopic structures that manipulate light. This natural engineering has inspired researchers to study butterfly wings for potential use in anti-counterfeiting technology and optical devices. Life in the Amazon is not restricted to the land. The river and its tributaries contain over 2,500 fish species, more than any other river system on Earth. Some are tiny and beautifully patterned, while others, like the arapaima, grow to over 3 meters long and can weigh more than 200 kilograms. Piranhas, often misunderstood, play a crucial role in keeping ecosystems healthy by scavenging carcasses and preventing disease spread. Electric eels generate powerful shocks that help them hunt and communicate, demonstrating just how creative evolution can be in shaping survival strategies. The rainforest's biodiversity is deeply interconnected. Many species depend on specific relationships to survive. Orchids pollinated by a single type of bee, figs eaten by bats that disperse seeds across great distances, and trees whose seeds germinate only after passing through the digestive tract of certain animals. Disrupting one link in this chain can have cascading effects, illustrating how delicate and finely balanced the ecosystem truly is. Despite its richness, the Amazon remains poorly understood. Scientists estimate that they discover a new species every 2 days, yet countless others may disappear before they are ever identified. The forest's immense size and difficult terrain make exploration challenging, while rapid changes caused by climate shifts and human activity add urgency to the work of biologists and conservationists. One factor that contributes to Amazonian biodiversity is the region's stable climate over millions of years. Unlike other parts of the world that experienced repeated glaciation, the Amazon remained warm and humid, allowing species to evolve and diversify without major interruptions. Rivers also play a crucial role. As they change course over time, they isolate populations of plants and animals, leading to the formation of new species through a process known as allopatric speciation. This continuous reshaping of the landscape is one of the driving forces behind the rainforest's unmatched variety of life. Yet the Amazon's biodiversity is not invincible. Deforestation, habitat fragmentation, and climate change threaten the delicate web of species that has taken millions of years to evolve. When forests are cut or burned, countless organisms lose their homes. Some can adapt or relocate, but many cannot. Scientists warn that the region is approaching ecological tipping points that could permanently alter its biodiversity. Still, hope remains. Conservation efforts, indigenous knowledge, protected areas, and international scientific collaboration are helping to safeguard this biological treasure. Understanding the extraordinary biodiversity of the Amazon is the first step toward protecting it. Each species, no matter how small or seemingly insignificant, plays a role in the greater tapestry of life. In the end, the Amazon is not just a forest. It is a living masterpiece of evolution, a heartbeat of life on Earth. It's a place where nature experiments, adapts, and thrives in ways that defy imagination. To explore it is to witness the full creative power of life itself. Deep within the Amazon rainforest, far beyond the reach of roads, cities, and modern technology, live some of the most isolated human communities on Earth. These groups, often referred to as uncontacted or voluntarily isolated tribes, maintain lifestyles that resemble those of ancient hunter-gatherers. Their world exists almost entirely outside the influence of modern civilization, preserved across thousands of years through tradition, knowledge, and a profound connection to the forest. To understand them is to glimpse humanity's past and to reflect on the delicate balance between culture, survival, and nature. Scientists estimate that over 100% uncontacted or isolated tribes may live in the Amazon basin, primarily in Brazil, Peru, and Colombia. Brazil alone officially recognizes more than 28 confirmed uncontacted groups, though the true number may be much higher. These communities are not primitive, rather, they are people who have chosen, either actively or through necessity, to avoid sustained contact with outsiders. The forest offers everything they need: food, shelter, medicine, and spiritual significance, making outside contact unnecessary and often dangerous. For many tribes, isolation is a choice rooted in history. Over the past centuries, waves of colonial expansion, rubber extraction, and illegal logging have brought violence, disease, and displacement to indigenous peoples. Millions died from epidemics following contact with Europeans, as they had no immunity to foreign illnesses. As a result, some groups retreated deeper into the forest, choosing voluntary isolation to ensure cultural survival. Their decision reflects not ignorance of the outside world, but a deep understanding of its risks. One of the most iconic uncontacted groups is the Flecheros, or Arrow people, named for their long bamboo arrows used for hunting and defense. Little is known about them because they avoid direct interaction, but aerial images taken from safe distances show their small thatched huts, cultivated gardens, and communal living areas. Observations suggest that they rely on a combination of hunting, fishing, and small-scale agriculture, a balanced lifestyle similar to ancient human societies. Another example is the Mashco-Piro people of Peru, who live in the remote Manu region. For decades, they avoided contact entirely, but in recent years, sightings along riverbanks have increased due to disturbances caused by illegal logging and mining. When they appear, they communicate through gestures, sometimes requesting tools or food, yet still maintain a cautious distance. Their behavior reflects the precarious situation many tribes face, as environmental pressures force them closer to areas visited by outsiders. Language is one of the most precious aspects of these communities. The Amazon is home to over 300 indigenous languages, many belonging to families that are thousands of years old. Some languages are spoken by only a few hundred people, and several are considered language isolates, meaning they have no known relation to any other language on Earth. Each represents a unique worldview, with words for plants, animals, and spiritual concepts that do not exist elsewhere. When a tribe disappears, an entire linguistic universe vanishes with it. Daily life for uncontacted tribes revolves around the rhythm of the forest. Men typically hunt using bows, blowguns, or spears, targeting animals such as peccaries, monkeys, and birds. Women gather fruits, roots, and medicinal plants, while also caring for children and maintaining gardens of cassava, maize, and bananas. These practices are not random, but deeply informed by ecological knowledge passed down through generations. Many tribes can identify hundreds of plant species and know exactly how to use them for food, shelter, or healing. Their understanding of medicinal plants is particularly remarkable. Indigenous healers, often referred to as shamans, act as spiritual leaders and doctors. They use plants like ayahuasca, chacruna, and dozens of lesser-known species for ritual purposes and healing ceremonies. Modern scientists have discovered that some of these plants contain powerful bioactive compounds, supporting the idea that indigenous medicine is based on careful observation and sophisticated knowledge rather than superstition. Social structures in these tribes are typically small and flexible. Groups may consist of 20 to 150 individuals, forming extended families that move seasonally to follow food sources. Decision-making is communal, often guided by elders who have accumulated decades of experience. Conflict within the tribe is rare, as cooperation is essential for survival. Their societies emphasize sharing, mutual care, and balance with nature, values that have allowed them to endure for thousands of years. Spirituality is woven into every aspect of life. Many tribes believe the forest is alive with spirits, each plant and animal possessing its own essence or power. Rituals, songs, and dances help maintain harmony with these forces. The concept of ownership is different from modern societies. Land is not something to possess, but something to protect and use responsibly. This worldview fosters sustainability, ensuring the forest remains healthy for future generations. Despite their resilience, uncontacted tribes are among the most vulnerable populations on the planet. Their isolation means they lack immunity to common diseases. Even minor illnesses like the flu or measles can be devastating, causing mortality rates of up to 50% after initial contact. This is why governments in Brazil, Peru, and Colombia enforce strict non-contact policies, creating protected territories where entry is prohibited. These laws aim to prevent accidental contact and preserve cultural sovereignty. However, threats continue to grow. Illegal logging, mining, drug trafficking, and land grabbing push deeper into previously untouched areas. Satellite images reveal increasing forest fragmentation, which forces tribes into unfamiliar territories, heightening the risk of violent encounters or disease exposure. In recent years, several uncontacted groups have been observed fleeing bulldozers or hiding from aircraft, a stark reminder of how fragile their existence is. At the same time, indigenous advocacy groups and environmental organizations work tirelessly to defend these communities. Guardians of the forest, often composed of indigenous monitors, patrol vast territories to detect illegal activities and report them to authorities. Their efforts have helped establish some of the world's largest protected indigenous lands, safeguarding both cultural heritage and biodiversity. Understanding uncontacted tribes also challenges modern assumptions about progress and civilization. These communities demonstrate that alternative ways of living, self-sufficient, cooperative, deeply connected to nature, can endure for millennia. Their societies are not remnants of the past, but successful adaptations to one of the world's most demanding environments. In many ways, they hold knowledge that the modern world is only beginning to appreciate, from sustainable agriculture to plant-based medicine. In the end, the tribes of the Amazon represent one of humanity's last living links to our ancient origins. They are living archives of cultural and ecological wisdom, surviving through knowledge passed down across thousands of years. Their future depends on our ability to protect their lands, respect their choices, and recognize their right to live free from interference. To learn about them is to be reminded of the extraordinary diversity of human life and the importance of safeguarding every form it takes. The Amazon rainforest has long been a place of mystery, an immense green world that has drawn explorers, adventurers, scientists, and dreamers for centuries. For many, the Amazon promised lost civilizations, undiscovered cities, and secrets hidden beneath an almost impenetrable canopy. But it has also claimed countless lives, earning a reputation as a graveyard for the unprepared. The history of expeditions into the Amazon is a remarkable blend of ambition, danger, scientific curiosity, and human determination. One of the most legendary figures in Amazonian exploration is Colonel Percy Harrison Fawcett, a British explorer whose disappearance remains one of the greatest unsolved mysteries of the 20th century. Fawcett believed that a sophisticated ancient civilization once existed deep within the rainforest, a place he called simply Z. His obsession with this city consumed him for decades, leading him to undertake multiple expeditions across uncharted regions of Brazil. In 1925, accompanied by his son Jack and Jack's friend Raleigh Ramel, Fawcett set off on what he believed would be his final journey. The trio vanished without a trace. Despite dozens of follow-up searches, no confirmed remains were ever found, and Fawcett's fate continues to inspire books, films, and speculation. Though many dismissed Fawcett's theories as fantasy, modern archaeology has shown that he may have been far closer to the truth than his critics believed. For years, the academic view held that the Amazon could not support large, complex societies due to poor soil quality and the difficulty of sustaining agriculture. But evidence emerging in the last few decades has challenged that perspective. Researchers have uncovered signs of pre-Columbian urban networks, including geometric earthworks, vast road systems, and interconnected settlements that suggest a population numbering in the millions before European contact. One of the most intriguing discoveries is the presence of geoglyphs, large geometric shapes carved into the earth, often stretching hundreds of meters across. These structures, found in Brazil's Acre State and parts of Bolivia, date back at least 2,000 years. Their purpose remains unclear, but many scientists believe they were ceremonial or social gathering spaces. The precision of their designs indicates a level of organization that contradicts the long-held idea that Amazonian societies were small and scattered. Another groundbreaking piece of evidence comes from the study of terra preta, or black earth. This dark, fertile soil is found in patches across the Amazon basin and is believed to be the result of ancient human activity. Created by mixing charcoal, bone fragments, food waste, and organic matter, terra preta remains far more fertile than natural Amazonian soil and can regenerate itself over time. Its widespread distribution implies that ancient Amazonians were skilled agricultural engineers, capable of turning poor soil into productive farmland. These modern discoveries echo the accounts of early European explorers, such as Francisco de Orellana, who in 1542 became the first known European to navigate the entire length of the Amazon River. According to his reports, he encountered large, thriving settlements with complex political structures and dense populations. For centuries, historians dismissed his claims as exaggerations, assuming that disease and displacement had erased evidence of these societies by the time later explorers arrived. But modern research suggests that Orellana may have been one of the few outsiders to witness these civilizations at their height. The search for lost cities continued into the 20th century. Explorers such as Theodore Roosevelt, who embarked on the dangerous River of Doubt expedition in 1913 to 1914, faced life-threatening challenges from disease, starvation, and violent rapids. Roosevelt himself nearly died from infection during the journey, and several members of the team perished. The expedition eventually succeeded in mapping the river, now named the Roosevelt River, but it highlighted just how perilous Amazonian exploration can be. As time passed, exploration of the Amazon shifted from heroic quests to more scientific endeavors. In the late 20th and early 21st centuries, archaeologists, ecologists, and geographers began using advanced technologies to study the rainforest without disturbing it. One of the most transformative tools is LIDAR, a remote sensing method that uses lasers to penetrate the forest canopy and create detailed 3D maps of the ground below. LIDAR has revealed an astonishing landscape: grids of ancient roads, raised fields, fortified settlements, and structures hidden beneath layers of vegetation. In 2022, researchers working in Bolivia's Llanos de Morros region used LIDAR to uncover the remains of large pre-Hispanic urban centers built by the Casarabe culture between AD 500 and 1400. These settlements included monumental platforms, causeways, reservoirs, and pyramidal structures up to 22 meters tall. This discovery provided some of the strongest evidence yet that complex societies once flourished in the Amazon, rewriting long-held assumptions about the region's history. Modern explorers like Douglas Preston, Michael Heckenberger, and Anna Roosevelt have contributed significantly to reshaping our understanding of Amazonian archaeology. Heckenberger's work in Brazil's Upper Xingu region revealed the presence of garden cities, carefully planned villages connected by wide roads and surrounded by defensive earthworks. These findings suggest that far from being untouched wilderness, parts of the Amazon were shaped and engineered by human hands for centuries. Yet despite these advances, the Amazon remains one of the least explored places on Earth. Vast areas are still unmapped, and many archaeological sites are inaccessible due to dense vegetation, swamps, or conservation laws protecting indigenous territories. Even with modern tools, exploration continues to demand patience, physical endurance, and respect for the rainforest's delicate ecosystems. The dangers faced by explorers have not disappeared. In 2022, British journalist Dom Phillips and Brazilian indigenous expert Bruno Pereira were tragically killed while documenting illegal activity in the Javari Valley, one of the most remote and lawless regions of the Amazon. Their deaths highlighted the ongoing risks involved in exploring or documenting this vast territory, especially in areas controlled by criminal organizations or threatened by environmental conflict. Despite these challenges, exploration today is driven not by conquest or treasure hunting, but by a desire to protect and understand the rainforest. Scientists study ancient settlements to learn how past societies lived sustainably in a fragile environment. Conservationists work alongside indigenous communities to map territories and monitor threats. And researchers continue to use LIDAR, satellite imaging, and drones to reveal more of the Amazon's hidden past without disrupting the present. The story of Amazonian exploration is a powerful reminder of how much remains unknown. Beneath the forest floor lie secrets of ancient civilizations that thrived where few believed it possible. The dreams of explorers like Percy Fawcett, once dismissed as fantasy, are now supported by evidence uncovered through modern science. The Amazon continues to be a place where myth and reality meet, where new discoveries challenge our understanding of history, and where the spirit of exploration still burns brightly. The Amazon rainforest is often called the lungs of the earth, but it is also one of the most important natural pharmacies on the planet. Stretching across 9 countries and home to an estimated 390 billion trees and 16,000 species, the Amazon represents a living laboratory filled with compounds that could transform modern medicine. Scientists estimate that the rainforest contains more than 80,000 plant species, yet fewer than 5% of them have been studied for their medicinal potential. And at the heart of this knowledge lies another truth. Indigenous tribes have been using many of these plants for thousands of years, preserving a medical tradition that predates recorded history. Many of the medicinal breakthroughs we rely on today were discovered first in the Amazon. One of the most famous examples is the cinchona tree, native to parts of South America. Its bark contains quinine, the first effective treatment for malaria. For centuries, the Quechua people used cinchona bark to reduce fever. Spanish colonizers later brought the knowledge to Europe, where quinine became essential in saving millions of lives. This early discovery demonstrated that rainforest plants could hold the key to curing some of humanity's most difficult diseases. The Amazon's medical potential extends far beyond quinine. Today, scientists study compounds from plants, fungi, and even animals in the region to develop treatments for cancer, infections, neurological conditions, and autoimmune disorders. One promising example is the cat's claw vine, known locally as Una de Gato. Indigenous healers have used it for generations to treat inflammation, wounds, and stomach issues. Modern laboratory studies have shown that cat's claw has strong anti-inflammatory and immune-modulating properties. Researchers are exploring its active compounds as potential treatments for arthritis and chronic inflammatory diseases. Another plant with growing scientific attention is dragon's blood, a deep red sap harvested from the Croton lecleri tree. Indigenous communities use it to treat cuts, infections, and digestive problems. The sap contains a compound called croflemmer, which the US Food and Drug Administration has approved for treating HIV-related diarrhea. This is one of the few examples of a traditional Amazonian remedy becoming a modern pharmaceutical drug through rigorous clinical testing. The rainforest is not only a source of plant-based medicine, it is also home to powerful animal-derived compounds. One of the most remarkable discoveries involves the poison dart frog. The bright-colored species of the Amazon secrete potent alkaloids through their skin, some of which have pain-killing properties far stronger than morphine. Although the wild frog's alkaloids come from their diet and are difficult to replicate in captivity, chemists have synthesized similar compounds that show promise as non-addictive pain medications. Another example is the Brazilian wandering spider, whose venom contains a molecule being investigated for improving blood flow and potentially treating erectile dysfunction. While the spider is known as one of the most venomous in the world, its toxins demonstrate how natural compounds, even from dangerous animals, can inspire medical innovation. Yet perhaps the greatest repository of medical knowledge in the Amazon lies not just in plants or animals, but in the wisdom of indigenous communities. More than 300 tribes live in the rainforest, and many maintain medical traditions passed down orally through generations. To them, plants are not simply resources, but essential partners in survival. The shamans, or healers, of these communities often possess knowledge accumulated over centuries, understanding how to prepare specific remedies, how to combine plants, and how to avoid dangerous interactions. Scientists are increasingly recognizing the value of this knowledge. Ethnobotanists, researchers who study how people use plants, often rely on indigenous guidance to identify species with medicinal potential. Studies have shown that plants used in traditional remedies are significantly more likely to contain bioactive compounds than randomly selected species. In other words, indigenous medicine acts as a map, pointing modern researchers toward the most promising cures. One of the most complex examples of this connection is ayahuasca, a ceremonial brew used by numerous tribes for spiritual and healing purposes. The drink is made by combining two plants, Banisteriopsis caapi, which contains MAO inhibitors, and Psychotria viridis, which contains the psychoactive compound DMT. On their own, neither plant produces a long-lasting effect, but together, they create a powerful experience that affects the brain in unique ways. Neuroscientists studying ayahuasca are exploring its potential for treating depression, PTSD, and addiction. How indigenous communities discovered this precise combination of plants, out of tens of thousands of species, remains one of the Amazon's greatest mysteries. Despite its vast medical potential, the Amazon faces unprecedented threats. Deforestation, mining, agricultural expansion, and illegal logging destroy more than 10,000 square kilometers of forest each year. With each loss of habitat, species disappear, often before scientists have had a chance to study them. Many researchers warn that we may be losing plants that contain life-saving compounds without ever knowing they existed. The United Nations estimates that up to 137 species disappear from tropical forests every day, many of them in the Amazon. The danger is not just ecological, but cultural. Indigenous knowledge is vulnerable as tribes face displacement, violence, and erosion of traditional lifestyles. When shamans pass away without passing on their knowledge, humanity loses irreplaceable medical insights. Some organizations are working to preserve these traditions by documenting remedies, supporting indigenous rights, and promoting sustainable harvesting practices. But the balance between conservation and exploitation remains delicate. One of the most innovative approaches to protecting Amazonian biodiversity involves bioprospecting agreements. These are partnerships between pharmaceutical companies, scientists, and indigenous communities that allow researchers to study rainforest species ethically and legally. In return, profits from any discoveries are shared with local communities, ensuring that benefits do not flow solely to corporations. While not perfect, these agreements offer a model for respecting both nature and traditional knowledge. Modern genetic research has also opened new possibilities. Scientists use advanced techniques to analyze plant DNA and identify genes responsible for producing medicinal compounds. This allows them to understand how plants defend themselves against pathogens and stress, mechanisms that often create the chemicals useful in medicine. By mapping the genetic diversity of rainforest species, researchers can also predict which plants are most likely to contain novel compounds. But even with all these tools, the Amazon remains largely unexplored. New species are discovered every year. Some estimates suggest one new plant or animal is identified every 2 days. Each new species represents a potential breakthrough waiting to be uncovered. The rainforest's complexity, with its intricate webs of relationships between plants, insects, fungi, and microorganisms, means that many medicines may arise not from a single organism, but from interactions within the ecosystem itself. Nature's pharmacy is vast, mysterious, and fragile. The Amazon offers cures we have only begun to understand, from ancient remedies that have evolved over millennia to modern scientific innovations driven by indigenous wisdom. The rainforest stands as a powerful reminder of what we gain when we protect the natural world, and what we risk losing if we fail. The Amazon rainforest is home to some of the most extraordinary and fearsome creatures on Earth. For millions of years, life here has evolved under intense competition, dense vegetation, and an environment where survival often depends on specialized adaptations. From giant predators to venomous amphibians and mysterious shapes lurking beneath muddy waters, the rainforest is a place where nature shows both its beauty and its danger. It is no surprise that the people who live in these forests have developed legends of monsters, many inspired by real creatures with almost unbelievable abilities. The most iconic of the Amazon's creatures is the green anaconda, considered the heaviest snake in the world. Females can exceed 200 kilograms and stretch up to 7 meters in length, though unverified reports tell of even larger individuals. Despite their size, anacondas move silently through the water, relying on stealth rather than speed. They are ambush predators, capable of taking down caimans, capybaras, and even tapirs. An anaconda kills not with venom, but by constriction, tightening its coils each time the prey exhales. Scientists studying their anatomy have discovered that these snakes possess extraordinary muscle density, enabling them to exert crushing pressure far beyond what their size suggests. Yet despite their reputation, documented attacks on humans are rare. Another creature that captivates the imagination is the piranha, a fish often exaggerated in movies and books. While more than 30 species exist in the Amazon basin, only a few are considered truly dangerous. The red-bellied piranha, known for its powerful jaws and triangular teeth, can inflict serious injuries, but its reputation for skeletonizing animals in seconds is largely myth. These fish typically act as scavengers. They become aggressive mainly during the dry season when food is scarce. Experiments have shown that their bite force, relative to body size, is among the strongest of any vertebrate, a result of evolutionary pressure to crush seeds, fish, and carrion. Still, attacks on humans usually occur in shallow, disturbed waters, and fatalities are extremely uncommon. The jaguar, however, is a predator worthy of its legendary status. As the largest cat in the Americas and the third largest in the world, the jaguar is known for its immensely powerful bite. Studies show that jaguars have the strongest bite force of any big cat relative to body size, strong enough to pierce the shells of turtles or crush skulls. Unlike lions or tigers, jaguars often kill by biting directly into the brain of their prey. These magnificent animals roam vast territories of rainforest, often near rivers where prey is abundant. Because jaguars are elusive and primarily nocturnal, humans rarely encounter them, but their tracks and roars echo the raw power of the Amazon. Among the rainforest's smaller residents, few inspire more caution than the poison dart frog. These brilliantly colored amphibians produce some of the most potent toxins known in the natural world. The golden poison frog, for example, carries enough batrachotoxin to kill several humans. The indigenous Embera people traditionally used these toxins to tip their blowgun darts, giving the frog its name. Interestingly, researchers have discovered that these frogs acquire their toxins from their diet, mainly small ants and beetles, meaning captive bred frogs lose their deadly properties. This connection between environment and chemistry highlights the delicate, interconnected systems that sustain life in the rainforest. Other Amazonian creatures rely on stealth, speed, or deception. The giant centipede, known locally as the Scolopendra gigantea, can reach over 30 centimeters in length and uses venom to subdue its prey, which includes insects, lizards, and even small rodents. Its bite is extremely painful, and while not typically deadly to humans, it serves as a reminder that the rainforest is full of surprises. The electric eel, capable of generating shocks of up to 600 volts, uses electricity both to hunt and to defend itself. The eel's electrical discharge is powerful enough to knock a full-grown caiman unconscious. Scientists have studied the eel's electrical organs to develop new technologies in bioelectricity and robotics. Yet for every real creature that seems monstrous, the rainforest also contains stories of beings that exist somewhere between myth and reality. Indigenous tribes have passed these stories down for generations, often describing creatures that appear only in the deepest parts of the jungle or in the isolated river systems far from human settlements. Whether these legends are exaggerations of real animals or memories of species long extinct remains an open question. One of the most famous of these legends is the Mapinguari, a towering beast described as standing more than 2 meters tall, covered in long reddish hair, and emitting a foul odor detectable from a great distance. According to indigenous accounts, it walks on 2 legs and has a powerful roar. Some scientists believe the Mapinguari legend may be rooted in ancient memories of the giant ground sloth, a creature that went extinct around 10,000 years ago, but once roamed South America. Fossil evidence shows these animals were indeed massive, capable of standing upright, and covered in thick fur. Whether the legend is a cultural echo of this prehistoric giant or inspired by misidentified animals is unknown, but it captures the mystique of the region. Equally intriguing is the legend of the Yakumama, described as an enormous serpent or water spirit said to inhabit remote lagoons and river bends. According to local lore, the Yakumama can reach lengths of 50 meters and creates whirlpools by rising from the depths. While no scientific evidence supports the existence of such a creature, giant anacondas and other large aquatic animals could have inspired the myth. Stories of massive serpents appear in many Amazonian cultures, often serving as warnings about dangerous waters or the unseen power beneath the river's surface. Another mysterious figure of Amazonian folklore is the boto, or river dolphin. While the real pink river dolphin is gentle and intelligent, local legends attribute supernatural qualities to it. Some stories claim that the dolphin can shape-shift into a human at night, luring people into the river. These myths reflect the deep connection between Amazonian communities and their environment, where animals are seen not just as creatures, but as spirits with influence over daily life. Beyond the legends and the dangers, the creatures of the Amazon play essential roles in maintaining the balance of the ecosystem. Predators like jaguars control populations of herbivores. Birds and bats disperse seeds across vast distances. Insects pollinate countless plant species. Even venomous or aggressive animals contribute to the survival of the forest, shaping its structure and ensuring its diversity. Understanding these creatures, both real and mythical, provides insight into how the rainforest functions as a living, breathing system. Modern technology allows scientists to explore the Amazon more safely and efficiently than ever before. Camera traps, drones, and acoustic monitoring systems have revealed species once thought extinct or unknown to science. Each year, researchers identify dozens of new species, from tiny insects to brightly colored birds. These discoveries remind us that despite centuries of exploration, the rainforest still holds secrets waiting to be uncovered. In the Amazon, the line between reality and legend often blurs. The creatures that roam the forest, whether documented by science or preserved in oral tradition, represent the deep mystery of one of Earth's last wild frontiers. Some are dangerous, others misunderstood, and many yet to be discovered. Together they embody the powerful spirit of the jungle, a place where life evolves in extraordinary ways, and where the unknown still thrives. The Amazon rainforest is so vast, dense, and complex that for centuries, much of it remained beyond the reach of human understanding. Early explorers could only observe what lay along the rivers or trails, leaving millions of square kilometers untouched and unmapped. But today, everything has changed. For the first time in history, satellites, drones, and advanced imaging tools allow scientists to see the Amazon from above, revealing patterns, structures, and secrets invisible from the forest floor. This new perspective is transforming our knowledge of the rainforest, uncovering ancient civilizations, tracking climate shifts, and documenting the forces reshaping one of Earth's most vital ecosystems. The revolution began with satellite technology. The first images of the Amazon taken from space in the 1970s provided an unprecedented view of the forest's enormous scale. Today, satellites operated by NASA, the European Space Agency, and South American institutions capture high-resolution images daily. These images allow scientists to monitor everything from changing river courses to seasonal vegetation cycles. One of the most valuable tools is the Landsat program, which has continuously photographed the Earth's surface for over 50 years. By comparing decades of data, researchers can track long-term changes in forest cover and climate behavior with remarkable precision. One of the earliest and most important discoveries from satellite monitoring was the alarming rate of deforestation. In the 1980s and 1990s, satellite images revealed the rapid expansion of cattle ranching and logging operations, particularly in Brazil. Scientists could quantify forest loss for the first time, showing that millions of hectares were being cleared at a pace impossible to detect from the ground. Today, satellite monitoring systems like LIDAR and PRODES, run by Brazil's National Institute for Space Research, provide near real-time alerts of deforestation. Authorities use these alerts to respond more quickly to illegal logging and land clearing, although enforcement remains a challenge in remote regions. Beyond tracking destruction, new satellite technology is helping scientists understand the Amazon's role in global climate regulation. The rainforest absorbs around 2 billion tons of carbon dioxide every year, acting as a powerful carbon sink. But recent data from NASA's Orbiting Carbon Observatory indicates that certain regions of the Amazon are now releasing more carbon than they absorb, largely due to fires and deforestation. Infrared sensors can detect hotspots and measure aerosol levels during burning seasons, providing crucial information about how these events affect air quality and climate patterns both locally and globally. While satellites reveal broad patterns across the forest, drones allow scientists to zoom in on specific areas with remarkable detail. Equipped with cameras, thermal sensors, and even multispectral imaging systems, drones can fly below the canopy or along riverbanks to collect data previously impossible to gather. Researchers use drones to study carbon storage in tree trunks, monitor wildlife populations, and document illegal mining operations hidden deep within the forest. Their flexibility and low cost have made them essential tools for local conservation groups, allowing even small teams to gather high-quality data without large budgets. The most transformative technology, however, is LIDAR, which stands for light detection and ranging. LIDAR uses laser pulses to penetrate dense vegetation and create high-resolution 3D maps of the ground beneath the canopy. Mounted on planes, helicopters, or drones, LIDAR systems can scan thousands of hectares in just a few hours. What they reveal has stunned archaeologists and ecologists alike. In recent years, LIDAR has uncovered evidence of large, complex ancient settlements hidden beneath the forest. In parts of Brazil and Bolivia, researchers discovered vast networks of roads, plazas, defensive structures, and geometric earthworks, suggesting that the Amazon once supported sophisticated civilizations far larger than previously thought. Some of these earthworks date back more than 1,000 years, and archaeological estimates suggest that millions of people may have lived in regions that were once assumed to be sparsely populated. These findings challenge the long-held belief that the rainforest was too nutrient-poor to support large societies. LIDAR has also transformed ecological research. By mapping individual trees and measuring the height of the canopy, scientists can estimate biomass and carbon storage with extraordinary accuracy. Studies show that tall, old-growth forests store the most carbon, making them essential in efforts to combat climate change. Researchers can also use LIDAR to predict how forest structure changes after fires or logging, allowing conservationists to pinpoint the areas most in need of restoration. The ability to measure tree height and density from the air has fundamentally changed how scientists understand forest health. But the technology does more than map trees. It helps discover new species. Some scientists use drone-mounted LIDAR to identify unusual patterns in vegetation that may indicate unique ecosystems. When teams visit these hotspots on the ground, they often find rare plants, insects, or amphibians previously unknown to science. As many as hundreds of new species are identified each year, thanks in part to aerial exploration. Another powerful tool comes from satellites equipped with synthetic aperture radar, or SAR. Unlike optical sensors, SAR can see through clouds, a major advantage in the Amazon, where cloud cover can obscure the forest for weeks at a time. Radar systems can detect subtle changes in land surface height, track flooding events, and measure how much moisture the forest releases into the atmosphere. This moisture plays a critical role in generating rainfall not only for South America, but for weather systems around the world. Understanding these cycles helps scientists model climate change more accurately. Space-based monitoring has also transformed the way we study the Amazon's rivers. Using satellites like GRACE, which measures changes in Earth's gravitational field, scientists can detect fluctuations in groundwater levels. This helps track droughts, river dynamics, and the health of wetlands such as the Pantanal, the world's largest tropical wetland. These water systems support countless species and help regulate the region's climate, making them essential to understanding the rainforest as a whole. Yet despite the incredible advances in technology, the Amazon remains full of mysteries. Many areas are still poorly mapped, and dense cloud cover or rugged terrain can limit aerial imaging. Some archaeological sites remain hidden beneath thick root systems, requiring careful ground exploration. And while technology can reveal where deforestation is happening, it cannot always tell us why or how to stop it. Protecting the rainforest still depends on political will, sustainable practices, and respect for the people who call the Amazon home. Even so, the view from above has changed everything. We now understand the Amazon not as an endless, impenetrable green mass, but as a living landscape full of history, complexity, and change. From ancient cities buried beneath the trees to carbon cycles that influence the entire planet, the secrets revealed by satellites, drones, and LIDAR are painting a clearer picture of one of Earth's most important ecosystems. As technology continues to evolve, so too will our knowledge of the rainforest. New satellites will provide even sharper images. More advanced drones will explore areas too remote or dangerous for humans. And LIDAR systems will continue to peel back the layers of the jungle, revealing stories written long before modern civilization existed. The Amazon, once considered unknowable, is slowly giving up its secrets. One scan, one photograph, and one laser pulse at a time. The Amazon rainforest is often described as the lungs of the earth, a poetic phrase used to express its importance in sustaining life on our planet. While the metaphor is not scientifically precise, the forest does not literally produce most of the oxygen we breathe. It does capture a crucial truth. The Amazon plays an essential role in regulating global climate systems, stabilizing water cycles, and balancing the planet's carbon budget. Losing it would not simply be a regional tragedy. It would disrupt the environmental stability of the entire world. To understand why the Amazon is so important, we must begin with its sheer size. Covering more than 5.5 million square kilometers, it is the largest rainforest on Earth, containing approximately 390 billion trees and representing nearly 40% of the world's remaining tropical forests. This massive green expanse acts as a global thermostat. Every tree, every plant, and every drop of water participates in a silent, continuous exchange of gases and moisture that influences weather patterns far beyond South America. Scientists estimate that the Amazon recycles about half of the rain that falls on it, a process driven by the forest itself. This cycle begins with evapotranspiration, a process where trees absorb water through their roots and release it back into the atmosphere through their leaves. In the Amazon, this releases an astonishing 20 billion tons of water into the air each day. To put that in perspective, it is more water than the daily flow of the Amazon River itself, the largest river in the world. These massive columns of water vapor rise, cool, and condense into clouds that help generate rainfall across vast regions, including agricultural zones in Brazil, Argentina, and Paraguay. Some of this moisture travels even farther, influencing rainfall patterns as far away as the western United States and northern Africa. The forest's influence on water does not stop at the atmosphere. The Amazon River system acts as the circulatory system of the rainforest. Fed by thousands of tributaries, it carries nearly 20% of the world's fresh water, shaping coastlines and nourishing marine life in the Atlantic Ocean. The river also helps regulate the heat balance of the region, cooling the land through evaporation and maintaining stable temperatures that support millions of species. When forests are removed, the land becomes hotter, drier, and more vulnerable to fires, conditions that were once extremely rare in the Amazon. Another key function of the rainforest lies in carbon regulation. Through photosynthesis, trees absorb carbon dioxide and store it in their trunks, leaves, and roots. Over centuries, the Amazon has become one of the most important carbon sinks on the planet. Estimates suggest that the rainforest stores around 150 to 200 billion tons of carbon, an amount equal to more than 15 years of global carbon emissions from human activity. But this balance is fragile. When trees are burned or cut down, the carbon stored inside them is released back into the atmosphere, contributing to global warming. Unfortunately, satellite data from the past decade shows that certain parts of the Amazon are no longer functioning as carbon sinks. Instead, they're becoming carbon sources, releasing more carbon dioxide than they absorb. The primary drivers are deforestation, forest degradation, and more frequent fires. Human activities, especially cattle ranching, soy cultivation, illegal logging, and mining, are major contributors. When combined with rising temperatures and prolonged dry seasons, the forest becomes more vulnerable. Fires spread more easily, trees grow more slowly, and the delicate balance of the ecosystem begins to break down. This shift has profound implications for global climate stability. If the Amazon passes a critical tipping point, scientists warn that it could enter a process known as dieback, where large sections of rainforest gradually transition into savanna-like ecosystems. This would reduce rainfall, increase temperatures, and release massive amounts of carbon stored in vegetation and soil. Some climate models suggest that if deforestation reaches 20 to 25%, parts of the Amazon could tip into irreversible change. Today, estimates place deforestation at around 17%, alarmingly close to the danger zone. The Amazon also plays a crucial role in maintaining biodiversity, which in turn supports climate stability. Diverse ecosystems are more resilient to changes in temperature and rainfall. They can adapt, recover, and continue storing carbon. But when species disappear and habitats are fragmented, the forest becomes less resilient. For example, the loss of large mammals like tapirs and primates. Animals that disperse seeds of large carbon-rich trees can lead to long-term shifts in forest composition. Over time, smaller, fast-growing trees dominate, storing less carbon and weakening the forest's overall health. The climate consequences extend far beyond carbon. The Amazon influences atmospheric circulation patterns that affect weather across continents. Scientists describe the rainforest as a biomechanical pump, pulling moist air from the Atlantic Ocean and pushing it across South America. When large areas are cleared, this pump weakens. Rainfall becomes less predictable, droughts more frequent, and extreme weather events more severe. In recent decades, the Amazon has experienced several significant droughts. In 2005, 2010, and 2015 to 2016, events once considered rare but now increasingly common. Despite these challenges, there is still hope. Conservation efforts, reforestation projects, and technological innovations are helping protect the forest and restore damaged areas. Indigenous communities who have lived in harmony with the rainforest for thousands of years are some of its most effective guardians. Studies show that deforestation rates are significantly lower in territories managed by indigenous peoples compared to areas without protection. Their deep knowledge of the land provides valuable guidance for sustainable forest management and climate resilience. International cooperation is also essential. Programs like the Amazon Fund, supported by countries such as Norway and Germany, finance conservation initiatives and sustainable development projects. Meanwhile, emerging carbon markets offer economic incentives for protecting forests rather than clearing them. Some companies and governments are working to develop systems where carbon credits reflect the true value of keeping trees standing. While imperfect, these efforts represent steps toward aligning economic interests with environmental goals. New technologies are also contributing to solutions. Satellite monitoring systems detect illegal logging in real time, enabling faster response from authorities. LIDAR mapping helps identify areas that are most important for biodiversity or carbon storage. Drones support reforestation by planting seeds in hard-to-reach areas. Together, these tools offer a more precise understanding of where interventions will have the greatest impact. Ultimately, the Amazon's role in global climate is both monumental and irreplaceable. It maintains rainfall, regulates temperatures, stabilizes carbon cycles, and supports life on an extraordinary scale. Yet it is also at its most vulnerable moment in modern history. The decisions made in the coming years by governments, industries, and communities will determine whether the Amazon continues to serve as a life support system for the planet or becomes a source of instability and decline. The rainforest's fate is deeply connected to our own. Protecting the Amazon means protecting the climate that sustains every form of life on Earth. It is a responsibility shared by all of us, and a reminder of the delicate balance that keeps our planet thriving. The Amazon rainforest is often described as a place of unparalleled natural beauty and biological wealth, but beneath its lush canopy lies another reality, one shaped by conflict, extraction, and the constant struggle for control over valuable resources. Illegal gold mining, logging, and land grabbing have transformed parts of the Amazon into zones of tension and exploitation. Far from the eyes of the world, powerful networks, ranging from criminal groups to multinational interests, compete for riches hidden within one of Earth's most biodiverse regions. These hidden wars threaten not only the forest itself, but the lives and cultures of indigenous communities who have called the Amazon home for thousands of years. Gold has long been one of the Amazon's most dangerous temptations. Throughout the rainforest, vast deposits of alluvial gold lie beneath layers of soil and river sediment. Rising global gold prices have fueled a dramatic surge in illegal mining, known locally as garimpo. In countries like Brazil, Peru, Venezuela, and Colombia, thousands of miners, often working in remote camps, use high-pressure water hoses and toxic chemicals like mercury to extract gold from the earth. The scale is staggering. Satellite images from the past decade show that illegal gold mining has expanded by more than 90% in the Brazilian Amazon alone, affecting over 6,000 square kilometers of forest. One of the most serious environmental consequences comes from mercury contamination. Miners use mercury to bind gold particles during processing, but much of it is released into rivers, where it enters the food chain. Studies have found that mercury levels in Amazonian fish can reach concentrations dangerous to human health. Many indigenous communities, who rely on river fish as their primary protein source, now face chronic exposure. In some regions of the Yanomami territory in northern Brazil, medical teams have documented mercury poisoning levels among the highest ever recorded in the Amazon. Mercury affects the nervous system, causing tremors, developmental issues in children, and long-term cognitive damage. Beyond mining, illegal logging represents another major threat. Though logging can be carried out sustainably in theory, much of the Amazon's timber trade operates in the shadows. High-value hardwoods like mahogany and ivy fetch thousands of dollars per cubic meter on international markets. Criminal logging networks use forged permits, bribe officials, and exploit loopholes to move timber across borders. According to environmental monitoring organizations, up to 80% of logging in parts of the Brazilian Amazon may be illegal. Once loggers remove the most valuable trees, they often leave behind degraded forest that becomes vulnerable to fire, opening the door for cattle ranchers and land grabbers. Land grabbing, known locally as grillagem, is perhaps the most complex and politically charged issue in the Amazon. Powerful actors, including ranchers and speculators, illegally occupy public lands, clear the forest, and later attempt to legitimize property claims with falsified documents. Over time, this practice has resulted in the conversion of millions of hectares of rainforest into cattle pasture. Brazil is now the world's largest exporter of beef, and more than 70% of deforested land in the Amazon ends up as grazing area. This expansion not only contributes to greenhouse gas emissions, but fuels violent conflicts with indigenous peoples who lose access to ancestral territories. Indigenous communities are often the first and most vulnerable victims of these hidden wars. Many territories suffer constant invasions from miners, loggers, and land grabbers. The Yanomami, Munduruku, and Kayapo peoples have faced particularly severe pressure. In remote regions, illegal mining camps often bring disease, violence, and exploitation. Malaria outbreaks have increased dramatically in areas with high mining activity, as stagnant water from mining pits becomes breeding grounds for mosquitoes. In some territories, indigenous leaders who resist invasions face threats, attacks, or assassination. According to human rights groups, dozens of indigenous defenders are killed across the Amazon each year. Yet these conflicts are not limited to criminal or informal actors. Large-scale infrastructure projects, such as hydroelectric dams, highways, and industrial agriculture, also play a role in reshaping the region. For example, the construction of massive dams on the Xingu and Madeira rivers has flooded thousands of hectares of forest, displaced local communities, and altered fish migration patterns. These projects often move forward despite legal challenges, illustrating the complex interplay between economic interests and environmental protection. In some cases, the very presence of new roads built for infrastructure opens access to previously untouched regions, accelerating deforestation and illegal activity. The international dimensions of the Amazon's hidden wars are equally significant. Gold extracted illegally from the rainforest often enters global supply chains through a series of intermediaries. By the time it reaches refineries in Switzerland, Dubai, or the United States, its illicit origins are nearly impossible to trace. Similarly, illegally logged timber, labeled with falsified documents, may end up in furniture stores or construction sites halfway across the world. As global demand for commodities grows, so does the pressure on the Amazon's natural resources. The political landscape surrounding these issues is complex. Governments across the Amazon basin have struggled with limited resources, corruption, and conflicting economic priorities. Enforcement agencies often lack the manpower to monitor such a vast territory, and criminal networks exploit remote areas where the state has little presence. Periods of LAX regulation or political instability can dramatically accelerate environmental degradation. For instance, during years when environmental oversight was weakened in Brazil, deforestation rates increased sharply, reaching their highest levels in over a decade. Despite these challenges, there are also powerful forces pushing for protection, justice, and sustainable development. Indigenous organizations have become increasingly vocal on national and international stages, advocating for stronger territorial rights and environmental safeguards. Many scientists, activists, and NGOs support community-led monitoring programs that equip indigenous groups with drones, GPS tools, and training to document illegal activity. These initiatives not only protect the forest but strengthen the autonomy and resilience of local communities. New technologies are also helping to shed light on the Amazon's hidden conflicts. High-resolution satellites can detect deforestation in near real time, enabling rapid response from environmental agencies. Artificial intelligence systems analyze patterns of land clearing, road construction, and mining activity. Researchers use remote sensing to identify areas at highest risk of illegal activity, while journalists and investigators have begun to expose the networks behind the black market trade in gold and timber. These tools make it harder for illegal operators to remain hidden, though the challenge remains immense. Another encouraging development is the expansion of sustainable economic alternatives. From forest-based products like acai, Brazil nuts, and natural rubber, to community-managed tourism and renewable energy projects, there are viable ways to generate income without destroying the rainforest. Some indigenous and traditional communities have built successful cooperatives that demonstrate how economic development and forest conservation can coexist. While these projects may not match the immediate profits of illegal mining or large-scale agriculture, they offer a long-term path that protects both people and the environment. The hidden wars of the Amazon are not simply battles over land or resources. They are part of a larger struggle over the future of the rainforest, and by extension, the future of the planet. Every tree cut, every river polluted, every community displaced contributes to a chain reaction that weakens the ecological stability of the entire region. Yet the Amazon's resilience should not be underestimated. With strong protections, empowered local communities, and a commitment to sustainable development, the forest can still recover and thrive. In the end, the story of the Amazon is a story of contrasts. It is a place of immense natural wealth, yet also a battleground for competing interests. It is home to peoples with ancient traditions, yet targeted by modern economic forces. And while the dangers facing the rainforest are urgent and real, so too are the efforts to defend it. The hidden wars of the Amazon reveal not only the threats to the forest, but the critical importance of protecting one of the most vital ecosystems on Earth. The Amazon rainforest stands at a turning point, unlike any moment in its long natural history. Scientists warn that the next few decades will determine whether this immense ecosystem recovers or collapses. Once spanning more than 5.5 million square kilometers, the Amazon has already lost close to 20% of its forest cover. Many researchers believe that crossing a threshold of around 25% deforestation could push the rainforest past a critical tipping point. If that happens, large parts of the Amazon could transform into dry savanna, unable to produce the rainfall needed to sustain its own climate. This would represent not just a regional disaster, but a global one. with profound consequences for biodiversity, weather systems, and the planet's carbon balance. The most urgent question is whether humanity can reverse this trajectory in time. Encouragingly, a growing alliance of scientists, indigenous communities, conservationists, and local governments is working to protect what remains. Their efforts combine advanced technology, ecological restoration, and traditional knowledge that has safeguarded the forest for thousands of years. In many ways, the Amazon's future depends on whether these different approaches can be scaled up quickly enough to counteract ongoing threats. One of the most important strategies is the creation and enforcement of protected areas. Studies consistently show that forests under official protection, especially those managed by indigenous communities, suffer far less deforestation than surrounding regions. Today, over 30% of the Amazon is designated as indigenous territory, national parkland, or conservation area. These territories serve as vital refuges for wildlife and essential buffers against climate change. Expanding these protected zones, while ensuring that governments respect and enforce their boundaries, remains one of the most effective tools for preserving the rainforest. Indigenous knowledge also plays a key role in safeguarding the forest's future. Communities such as the Kayapo, the Ashaninka, the Tikuna, and many others have developed systems of land management that maintain biodiversity while providing for human needs. They practice selective harvesting, sustainable fishing, and rotational agriculture that protects soil fertility. Their understanding of local ecosystems, based on generations of observation and experience, offers insights that modern science is only now beginning to appreciate. As the global community recognizes the importance of these knowledge systems, more programs are emerging that support indigenous-led conservation and empower local leaders to monitor and defend their territories. Technology is transforming the way the Amazon is studied and protected. High-resolution satellite networks, such as Sentinel, Landsat, and cloud-free LIDAR, provide near real-time monitoring of deforestation. These tools can detect illegal logging, mining, and land clearing within hours. Governments and NGOs use artificial intelligence to analyze satellite data, identify patterns of environmental crime, and alert enforcement teams before irreversible damage occurs. In some cases, drones operated by indigenous forest guardians patrol remote regions where officials cannot reach. These drones help document illegal activities, gather evidence, and deter invasions. Beyond surveillance, technology is also being used for ecological restoration. Scientists are experimenting with new methods to accelerate reforestation, such as seed-dispensing drones and automated planting systems. These innovations can plant thousands of seeds per day across areas that would otherwise be inaccessible. Yet experts agree that restoration must go beyond simply replanting trees. A functional rainforest requires a diversity of species, soil microbes, insects, and wildlife. Restoring these complex relationships takes time and often requires collaboration between scientists and local communities who understand the rhythms of the land. At the same time, major economic changes are necessary to ensure that the Amazon has a sustainable future. Much of the deforestation is driven by global demand for beef, soy, timber, and minerals. Redirecting these economic forces means creating incentives for sustainable agriculture, improving land use planning, and developing forest-based industries that protect the environment. Across the basin, communities are turning to products such as acai berries, Brazil nuts, natural rubber, and essential oils, resources that can be harvested without clearing the forest. These sustainable supply chains demonstrate that economic growth and environmental protection do not have to be opposing goals. Climate change presents another challenge that could determine the rainforest's fate. Rising temperatures, Prolonged droughts and shifting rainfall patterns are already reshaping the Amazon's ecosystems. Certain regions have experienced repeated droughts severe enough to cause mass tree mortality. These disturbances reduce the forest's ability to store carbon, making it more vulnerable to fires. Historically, the Amazon has been too wet to sustain large wildfires, but during the driest years, fires intentionally set by ranchers or farmers can burn out of control. Strengthening fire prevention programs, improving water management, and restoring climate-resilient tree species will be essential in increasing the forest's resilience. Governments play a crucial role in shaping the Amazon's future. Environmental policies, enforcement budgets, and land use regulations can either protect the forest or accelerate its destruction. Recent history shows this clearly. In years when governments strengthened environmental agencies and imposed stricter penalties for illegal activity, deforestation rates fell sharply. In years when environmental oversight was weakened or enforcement budgets were reduced, deforestation surged. The political landscape of Amazonian countries, Brazil, Peru, Colombia, Ecuador, and others, will therefore have a major impact on whether the rainforest survives. But government action alone is not enough. International cooperation is increasingly seen as vital. The Amazon influences weather patterns across the globe, from North America to West Africa, meaning that its preservation is not only a local issue, but a planetary one. Several global initiatives aim to finance forest conservation, support sustainable development, and compensate countries for protecting carbon-rich ecosystems. New proposals include creating an international Amazon fund backed by wealthy nations, developing transparent commodity supply chains, and expanding scientific partnerships across borders. There is also growing momentum behind bioeconomy initiatives. Renewable, forest-friendly industries that create jobs while keeping the forest standing. These range from sustainable fishing to medicinal plant research and community-managed ecotourism. Some scientists believe that the Amazon could become a global center for biotechnology, offering natural compounds with potential medical, agricultural, and industrial applications. This vision imagines a future where the Amazon is valued not for the minerals or timber extracted from it, but for the living systems it supports and the knowledge it contains. Ultimately, the future of the Amazon depends on the choices made today. The forest is resilient. It has endured ice ages, shifting continents, and millions of years of natural upheaval. But the pressures it faces now are unprecedented in speed and scale. If deforestation continues at its current rate, large parts of the Amazon will lose the ability to sustain themselves. Rainfall will decrease, river systems will shift, and biodiversity will collapse. Entire cultures that have thrived in harmony with the forest may vanish forever. Yet the story is not one of inevitable decline. Across the region, communities are fighting every day to protect their lands. Scientists are developing new tools to monitor and restore damaged ecosystems. Governments and international partners are beginning to recognize that the Amazon's value lies in its preservation, not its destruction. For the first time in decades, deforestation in some areas has slowed, offering a glimpse of what is possible when policy, science, and local leadership align. The Amazon stands at a crossroads, one path leading to collapse, the other to renewal. Whether the rainforest survives will depend on global cooperation, local empowerment, scientific innovation, and a shared recognition that the Amazon is not just a forest, but a lifeline for the entire planet. The next few decades will determine whether the world's greatest rainforest enters a new era of recovery or becomes a warning of what happens when we fail to protect the natural systems that sustain life on Earth. As our journey through the Amazon comes to an end, we are reminded of how fragile and extraordinary this rainforest truly is. Its rivers, its wildlife, and its ancient cultures form a living system unlike any other on Earth. A system still full of mysteries waiting to be understood. The future of the Amazon will be shaped by the actions we take today and by the stories we choose to keep alive. If you wish to continue exploring the hidden corners of our world, feel free to stay connected to this channel. Many viewers quietly subscribe or leave a small sign of support to help these calm, in-depth documentaries reach others who enjoy them. Until next time, may the spirit of the rainforest stay with you, deep, peaceful, and enduring.